1 is that function, sigma 0 is that function, and ma is that function. And this comes from, I don't know, probably smart people, or government people, I don't know. Right, so this means like a bitwise, I think a bitwise rotation by 6 bits.
Yeah, so bit shift to the right.
Yeah, that's what I guess. But it's a rotation, so it doesn't. Yeah. These are XORs. These are bitwise ands, bitwise not. So it's some nonlinear thing. It better be nonlinear because. So the point is, this is invertible. I mean, so here all I've done is I've XORed information into this register H and I put it here. But we can go backwards because we can just XOR the opposite information. I mean, so we could take this. Believe me. Actually, sorry. Oh, we don't have to go backwards. This is SHA. It's compression, so it doesn't actually matter. All right. So anyway, this is what it is. It's some messy thing, and you repeat this messy thing 64 times. So essentially, that eight full cycles. Each of these is a shift by 1 over 8. So if you do it 64 times, there's 8 full cycles of this whole thing. So it's a really messy function. So this is called SHA-256. And it's supposed to be a mess because it's supposed to satisfy this property here. Given Z, it should be in 0, 1 to the 256, it should be very hard to find a preimage. Something of that value. It should be hard to invert the function on Z. That's what we want. So this is useful, for example, here, I mean, it's useful in lots of reasons. Here, say for signing download. So if you download like an operating system update or something onto your computer, you want to know it's actually from Microsoft or Apple or whoever, and not from the Russian hackers. Right. So what you do is after you download it, you double check that the hash is the same as what it should be. So in other words, you evaluate the SHA function on you break it up into lengths of 256 bits. You evaluate the SHA function on each of them, maybe like XORing them into each other. Yeah, there's some chaining going on to make it fancy, I think. And you call that SHA of the download, and then you go onto Apple's website or something, and you double check that SHA of your download is equal to the number that they published on their website to make sure that you've actually gotten the official download. Because the hackers couldn't come up with a fake download that had the same hash. That would be hard.